Alright guys, we're going to go move on and talk about geometric sequences. So with this, basically, we talked about arithmetic at first. We noticed that with arithmetic, what was the thing it had in common every time as you went from one term to the next? Yep, is adding or subtracting by the same number. Which would we call that? The common difference. And what that means is, look at the example there, 1, 3, 5, 7. What's the common difference here? Perfect. So that's it. Common add or subtract by a certain number every time. And you guys can see that easier because it's add or subtracting. But basically what's going on is you're taking your second term and you're subtracting it from its previous term. So it's going to be 3 minus 1, 5 minus 3. And then 7 minus 5, and so forth and so on, and you're in and out with that same difference every time because you're subtracting. So let's go ahead and talk about geometric. With geometric, it's not the same difference. It's now called the same ratio, which means if you look at the next set of numbers, (3, 6, 12, 24). What are we doing every time there, guys? We're doubling it, multiplying it times 2. And you guys can see doubling pretty simple, but the idea is it's 6 now divided by 3. 12 divided by 6. 24 divided by 12. So now you're dividing each term to see what you get. And so we go through now and say, okay, since we know the both of them, one's being added and subtracted by the same number, the other one's being multiplied or maybe sometimes divided by the same number, now let's go ahead and just identify what the sequences in series are. So if you look at the A, to go from 12 to 36, and then from 36 to 108, what are we doing? Times 3, because 36 over 12 is equal to 3. 108 over 36 is equal to 3. Therefore, since there's a common ratio, it's geometric. And the common ratio is 3. What about B? What are you doing to go from negative 8, 1, 10 to 19? Exactly. Plus 9. So if there's a common difference of 9, that is going to be arithmetic. Look at C. Negative 1/3, positive 1/9, negative 1/27. Let's separate it. What's the numerator doing? The numerator. Still the same. So it's being multiplied times 1 or nothing's being done to it at all. Let's look at the denominator. What's it doing? It's multiplying times 3 every time, isn't it? But then also, what's happening to the signs? They are. So what's going on is your common ratio is not only 1/3, but it's also negative 1/3. Because now, if you multiply negative times negative, you get a positive. All right. Positive times a negative is a negative. Times a negative is a positive, times a negative is a negative, times a negative is a positive. See what I'm doing? Every time I multiply by a negative, I'm just alternating signs every time. So that's what's going on there. So the idea with geometric series is look at the value of it, and you could still do this. Even if you have the calculator, guys, you could still take 1/9 and divide it by negative 1/3. You could do that in the calculator. It could do the work for you. And then go on and say negative 1/27 over positive 1/9. And this would still be exactly the same. As a matter of fact, it'd be that one right there. So this is going to be geometric. What about D?
Geometric.
Why geometric?
Multiplying by negative 1.
Yep. It doesn't have to necessarily change the value. Just the fact you're changing the sign every time makes it geometric. Because the only way you can change a number of a sign without changing its value is multiplying by negative 1. That's the only way. So, come over here. That common ratio is negative 1. Therefore, it is geometric. Any questions from the two? Common difference, common ratio, vice versa. Alternating signs. Kind of some things you can see. All right. So let's look at the technical definition of what geometric sequence is. Sequence is geometric if the ratios of consecutive terms equal r, where r is not equal to 0. Number r is a common ratio of the sequence. The nth term of the sequence is, and this is the equation. So for arithmetic, you had a sub n is equal to a sub 1 plus d parentheses n minus 1. Be given to you. This will be given to you as well. But this is the way a geometric sequence or series is written as an equation. Your first term times your common ratio raised to the n minus 1 power. Every time n minus 1. So it says, find the common ratio for 3, 9, 27, 81, and 243. What is that, guys? 3. Not too bad. Then it goes on to say, write the first 5 terms. You know what? Let's just go ahead and write the equation for this one. It doesn't ask it, but we're just going to do it anyways. So we take the a sub n, as we always start our equations. Then we take our first value, which we've already started in the arithmetic as well. We take our first value as well. So what is the first value in this sequence, guys? 3. And then in parentheses, we put what ratio? What's that common ratio? What was the common ratio here? It's going to be the same number. Raised to the n minus 1. And that's it. First term, common ratio. That's all you need to know. Again, the only two things you need to know, first term, common ratio. For arithmetic, first term, common difference. So, still the same number of things you need to know. So write the first 5 terms of geometric sequence whose first term is negative 3. I'm going to go ahead and put that in the table. And whose common ratio is 2/3. Not really a fan right now of having to multiply by fractions, so let's just go ahead and do this. In the calculator, I'm going to go ahead in the calculator and go, all right, first time it's pretty easy. Negative 3, parentheses, alpha y equals 2 over 3 to make it a fraction. Negative 3 times 2/3. First time. You get negative 2. Then what I'll do now, guys, is this. I need to multiply it times negative 3 times 2/3 squared. Or, if we use recursion, guys, all I got to do is take this answer and do what to it? There you go. Times alpha y equals 2 over 3. And the good thing about that is, I can now just press enter every time, and it'll keep multiplying times 2/3 times 2/3. I don't have to type it all over again. So, negative 4/3 is next. Press enter again. Negative 8/9. Press enter again. Negative 16/27. So as you see in the calculator, you could always just type in the first problem here and then press times whatever it is you're doing every time. Times, times, times. Just keep pressing enter, okay? Questions so far, guys? Moving pretty fast. Right, so this one goes on to say, what is the 15th term of the geometric sequence whose first term is 20 and common ratio is 1.005? So, what is our first term again? What's our common ratio? 1.05. So, using the equation we talked about, a sub n equals, and what's the first thing we need to put in? The first term. So, 20 times that ratio. Well, this is the 15th term is what we need to find, right, guys? Raised to the 15 minus 1. 20 parentheses, 1.05 raised to the 14th power. I don't. I just truncate. You round or truncate is fine. I don't care. I just stop writing 3. I go 3 digits and just stop writing. So we do in AP Stat, so I do the same thing in Pre-Cal. It's a 1,000th off. I'm okay. I can live with that. All right, so what is the 12th term of the geometric sequence? Who's 5, 15, 45? So what is the first term, guys? 5. What's the common ratio? 3. So let's figure out what the 12th term is. 5 times 3 raised to the 12 minus 1 power. Oops, not divide. Pretty big number. I'll take that in dollar signs. There, make me feel better. Put a dollar sign, just make me feel better. All right, 885,735. Find the 8th term of the geometric sequence. 5, 5 halves, 5 fourths, 5 eighths. And it says put your answer in fraction. So first term is what again, guys? What is that common ratio every time? What are we multiplying by to get to the next one? Did y'all see 1/2? Yeah? Good. Again, it's the recommendation I gave you on day 1, guys. If you're looking at fractions when we're talking about sequences and series, treat them separately. Look at the top. What's the 5 doing on top? What's it being multiplied every time? 1. Look at the bottom. What's it being multiplied by every time? 2. So it's 1 over 2. Less painful than have to deal with 1/2 for some people. You hear fractions and you cringe. Now, hopefully we can just say 1 over 2. Maybe might deaden the sting a little. I don't know. So here we go. So with a to the 8th, so we go ahead and take our first term. Again, 5. We're multiplying by 1/2 every time, raised to the 8 minus 1. So 5 raised to the, and the good thing about the calculator, guys, if you use alpha y equals, which I hope you do by now, if you use alpha y equals and put it in fraction form, the calculator will give you the answer in fraction form. If you go in and put 0.5, it will give you in decimal form. Whatever the question is, they give you the answer back in that same form, okay? This ends up being 5 over 128. Oh. Here's see if I can make this one work. All right. Nope, I'm going to need extra room for this one, so scrolling up. So I can get by with having to... All right, so here we go. If a geometric sequence, so it tells you it's geometric, which means we're multiplying every time. Its 6th term is 64. Its 10th term is 1024. So we're counting by a certain number to get all the way from 64 to 1024, and we've done it. How many times did I have to multiply in order to get to 1024? Say it louder. 4. 6th term, 7th term, 8th term, 9th term, 10th term. That's 4 times I have to multiply by some common ratio. Do y'all follow what I'm saying? So here, it was not bad in arithmetic. You did the whole slope formula. Difference in the values divided by difference in the term numbers. This one's a little bit of a tweak from it, okay? When you found common difference, guys, what did you do to find your common difference every time? You subtracted. Good. You subtracted every time. You took your terms, right? What do we do now for common ratio? Divide. So we're going to do the same thing here. Let's go ahead and start off by dividing. Nothing's changed so far. We're dividing here. This is where it gets a little bit tricky. The problem is now if I divide this, that's great. You've told me a ratio, but you've told me a ratio that's been multiplied 4 times already. So if I take right now 1024 and divide it by 64, I get 16. What number can I multiply times itself 4 times and get 16? This is how we do it. And you guys are right. Common difference. Difference in values over difference in terms. Common ratio. I don't want to use different words, but the quotient, which means divide, by the root of the difference in terms. Do you see that 10 minus 6? Do you see where the 10 minus 6 comes from? You see where the 10 and the 6 come from? That's a difference in terms. Because that's how many times you had to multiply 2 in order to get from 64 to 1024. And you ask that question, and that question should be familiar. I asked you guys before, what number do I multiply times itself to get this? You're like, oh, wait, that's a square root type of deal. Wait, how many times do I need to multiply it? 4? Oh, that's a fourth root. How do I get fourth root? That's the difference in the term numbers. So it's going to be dividing your terms value and then taking the root of the difference of terms. It's really hard to explain that, guys, because it uses some really crazy vocabulary, but that's the idea. Yes?
How do you put the number in the on the calculator?
There is a math alpha window option 6. All right. So we have found now, guys, what that common ratio is, and that's usually the first big struggle. We found the common ratio. Next is try to find the first term. This all should be familiar to you guys. This is all exactly what we did in arithmetic sequences. Finding the common difference, finding the first term. Now we're just finding common ratio, finding the first term. How did we find the first term in arithmetic, guys, if we're given the common difference? We had this equation, which now it looks like this. We had this equation. Now we plug in, pick one set, pick a group. Pick sixth term is 64. 64 is equal to, I don't know what that is. I just found the common ratio to be 2 to 6 minus 1. So, you could easily do this. Oh, you guys before said, oh, common difference is 3, so I'm going to subtract 3, getting back to where I started. You could do the same thing here. 64, which now, it's not as easy as subtracting. Now we're dividing. Okay, sixth term is 64. I need to get to the first term. 64 divided by 2 is what? 32 divided by 2 is? 16 divided by 2. 8 divided by 2. Divided by 2 again. So 2. So I'm starting off with 2. That's a way of doing it if you need to. It's nice with 2, especially when it's an even number. Sometimes it's going to be a 1.37 or something. And now you're like, that's not as easy. And that's where this comes to play. Say, okay, here's this deal. 64 equals a to the first, 2 to the fifth. So 2 raised to the fifth is typo. Again. 32. All you have to do is divide by 32, right? You find out we were right. First term is 2. We divided by 2 every time and got to 2 where we needed to stop, and that's perfect. There we go. What's it actually asking for? It doesn't even ask the question. Equation does it. It just wants to know this. Done. It didn't want the equation from there. It just wants to know the first term. All right. Geometric series, or in other words, sum of geometric sequences, is what you've seen before already. You've seen the sum of arithmetic sequences. Now we're just going to go ahead and say, you know what? Those numbers that we're putting and adding together don't have a common difference. Now they have a common ratio. So, and we're dealing with this, guys. When we're dealing with multiplication, you can do it with 2 different ways. One, you can actually go to a stopping point. Okay? You can go on and say, I'm going to stop at a certain point. Or, this one, since you're multiplying, you can actually go to infinity. Adding, if I took a number 3 and added 2 to infinity, what would the sum of all those be? Do you know? If I take 3 and add 2, all the way infinite amount of time, took all those values, all those answers, add them up, what would we get? What does infinity mean? It's constantly. It's going to stop. It's never going to stop. So if it's never going to stop, we keep adding a 2 to it never stops. But then I keep adding that number. Is it ever going to get anywhere? No, it's never going to get anywhere. That's why in arithmetic, you only have one equation. S sub n equals n over 2 times first plus last. That's why you only have one. For geometric, guys, if I take a certain number and I start multiplying it by 1/2, yes, if you take a number and keep going 1/2, you can do that for infinity, guys. You know that, right? If I take 2 and divide it by 2 an infinite amount of times, will that ever stop? No. So the idea now is, well, how do you find the sum of that? Because we can do that. It's what it's approaching. It's like the asymptote. Remember the asymptote on a graph? It's getting closer and closer to this particular value, and that's what we're talking about. So first we're going to talk about is finite, which means it's actually going to stop somewhere. Okay? And so it's the sum. And as you can tell, this is just a fancy way of saying this is the sum of how it works. What we really need to focus on is that right there, the equation. It is your first term times 1 minus the ratio raised to however many terms you want to go out to, divided by 1 minus the ratio. So let's look. Find the sum of the first 9 terms of a geometric sequence with A1 is equal to 4, A2 is 4/3, so forth and so on. All right. So our first term is what, guys? 4. It goes from 4 to 4/3. What do you think we multiplied by? 1/3. How far out do they want us to go to find the sum? So, the formula is the sum up to 9 is going to be your first value times 1 minus, you said 1/3, raised to the 9th power over 1 minus 1/3. Bless you. So, bless you. So you can put this in your calculator right now. Press enter and see what you get. Another way is you can use a summation. Starting with 1 up to 9 of, what's your first term? 4, 1/3. Oops, you start with 0. Nope. X minus 1. Because that's the equation of a geometric sequence. So you have two options, however you want to do it. So I want this side to do the formula. I want this side to do the summation. See what happens. See how wrong I am. I'm on this side, so I'll do it with you guys. 4 parentheses alpha y equals. Or y'all can just wait till I do it. I don't know. Some people's working, thank you. Some people's waiting. Get to work.
How'd you get that?
Ooh, that took a while, huh?
When I did it, even if I put like the alpha y equals and separate it out, I still got an
See that one more time. Here?
Yeah.
So you put in 4 parentheses. Oh, because, and you did all this, right?
Yeah.
What did you get?
I got 1.99 repeating.
Can you do math, enter, and see what happens?
I got 39,364 over 6,561.
There you go. Sometimes those fractions are so bad, they'll be like, you know what? We're just going to give you as a decimal because it might be better. Sometimes, but yeah. The 1/3, did you put alpha y equals? Or did you put 1 divided by 3?
Math, enter to get that far?
Yes, I would always prefer a fraction. And if it can turn into a fraction, that'd be great. All right, so guys on your calculator, use the formula. Did you get 39,364 over 6,561? Bless you. Ryan, is that what you got? Oh, he's saving batteries. That's nice. Yeah. Something. Did you get decimal?
No, I haven't done it.
Oh, okay. Andy, is that what you got? You didn't get anything? Austin? This is good. It's not good. Hayden? No, gave me yes. I got what? Yes. Not got it. Still haven't done it. Man, I'm like 0 for 4 right now. Tyson, you did. You said yes?
Yeah.
I'm sorry. It was more like a yes question mark. Did you get this, Hayden?
Yes.
Yes, you
I
did.
got the 5.99. I didn't get the.
You got the decimal.
Yeah.
Did you have to convert it to fraction?
Yeah.
Okay, good. Thank you. Guys, when I say do it, please do it. Okay? I'm having you practice do it. Do you guys get the same thing on this side? Did you guys get the fraction, though? Y'all got the fraction. So I got the same thing. Tanner, did you not?
I got 112.
So did I. I did it both ways, and I got that number when I did it that way, and I got
Yeah.
112 when I did it this way.
That's funny.
I don't know how I got 112.
So I got the big fraction when I did the summation. I haven't done the first one yet. So when you do it, guys, are you doing 4 parentheses, alpha y equals 1 minus parentheses, alpha y equals again. Like anytime you see fractions, it's always good practice to put a fraction in the calculator because it's going to be able to do what you tell it to do. And unfortunately, the calculator is very literal. Maybe too literal. So, and I got the same thing again. So be careful not using the 1/3 or something. Did you use fraction alpha y equals, Tanner? You did? Okay. Guys, all right. So we got the answer. All right, perfect. So let's move on. Last page, guys. Last page. Final stretch. All right, here we go. Breaking down 8 minutes. Breaking down this one, find the sum of it. Well, the first term is going to be what, guys? 4. Good. What is that ratio? Good. 0.3. How many spaces are we going out? Good, John. Nice. So if we were to break down and use the formula here, S sub 12 is going to be, whoa. The first term, which was 4, parentheses, 1 minus 0.3 raised to the 12 minus, no, just 12th power, right? Over 1 minus 0.3. Calculator? Switch. Left side, do the summation. Right side, do the formula. And see what you get, guys. Ryan. Got it. What did I put?
Can you always give the answer in a fraction?
Yes, please. As ugly as it can be, but the good thing is you're letting the calculator do all the work so it can find the answer for you. Does this convert to fraction though? Nope. It'll give you still 5.71428 something because this cannot be converted to fraction. If that's the case, then go ahead and put in the decimal because you have to, okay? All right. For time purposes, guys, I'm going to skip number 9. It's just a word problem, but basically if we're to go through this, your first year's salary is going to be your A1, your rate. You got to be careful. The way they phrase this is perfect. I like it. You get 100% plus a 5% raise. So how much percent are you getting every year? 105. Very good. So actually it reads out to that. Please make sure we're doing that. Don't put your rate as 5%. You're getting 105% because you're getting a raise. And then you're going out for 20 years, okay? And we'll stop there. lastly, and this is what I think is interesting about this, and I always laugh at this idea. You see how many variables and how many terms are in the finite summation. Now let's go to infinity. So now let's take this 105% raise for this person that started off with $40,000 and do that for infinity. Let's say the guy just worked forever. Okay? In order to figure out what the sum is, his total compensation is going to be through his whole infinite amount of terms that he's at this job. It's as simple as take the first term and divide it by 1 minus the ratio. That's it. Once you take the first term and divide it by 1 minus the ratio, press enter in your calculator, you will get what the sum would be to infinity. I laugh at that because that is such a simple equation compared to what's up there. And this one goes to infinity. That one actually stops at a point. To me, it seems like it's backwards. To me, I feel like that would be smaller because you're stopping at a point. But this one goes on to infinity. So you think it's this long, elaborate equation when it's just, take your first value, 40,000, divided by 1 minus the 1.05%. So it ends up being 40,000 divided by negative 0.05. Press enter and you'll figure out what that adds up to if it went to infinity. There you go. That's it.